Hello and welcome to the section 3 of the course, the Bayesian Analyst Toolbox. Now in this section we are going to take a look at various points. We will learn about first of all priors, then we'll learn about the loss functions, and finally model evaluation. So let's start with the first video of section 3, choosing priors. Now in this video we are going to take a look at a couple of points. First of all, we will learn about what are the various priors available and also explain you the conditions inside it. So let's start. First of all, the prior distribution is Bayesian, or you can say Bayesian prior distribution. In the first point, you can see that prior is one's belief about the uncertain quantity. So basically, what is prior? Prior is basically one's belief. It is a belief about the uncertain quantity because you have no idea about that particular quantity, but you have a belief, and that is called prior. Second point, prior probabilities assigned to the event. So we can assign a prior probability. How we can assign? In the third point, you can see that prior can be assigned without any evidence. It is a true condition that if you have no evidence, still you can assign the probability to a particular event. The fourth point, prior can be assigned with the help of previous experiments. Absolutely true. If you have done previous experiments or if you have previous results or events, on the basis of that, you can assign a probability or prior to the particular event. And these are the important points inside Bayesian prior distribution. Now, if we talk about what are the levels of priors available here, so I have listed here few of them, like flat prior is available here, super vague but proper prior is available here, weakly informative prior is available here, generic weakly informative prior, and specific informative prior. So these are the levels inside priors. Let's start with flat prior. What is flat prior? In the first point, you can see all parameters are equally likely, right? Means all parameters are same, almost equal. They have the same weightage, we can say. Example is also available here, that what is the relationship between a person's height and weight. If I ask you that what is the relationship between a person's height and weight, what will be your answer? The answer can be anything, for example 2 kg per centimeter, anything, but that is not a flat prior. If someone tells me that the relationship between the person's height and weight is a billion, that is not an example of flat prior. The parameters are equally likely, then it can be a flat prior. So in the fifth point, you can see that if parameters are not likely, it is not a flat prior. Simple, right? If you are not sure about it, then that is not a flat prior. Vague prior. Uncertain or uninformed prior. It is also called uncertain or uninformed prior. Uniform, basically this is the range of vague prior. Uniform 0 to 100 or worse 0 to 1000. So this can be the range. You have no idea what is exact data, so you can simply provide the range of the prior. In the third point, you can see in condition of vague, don't specify any prior at all because you are uncertain about that. So there is no value to specify any prior or probability to that event. You have no idea. You are uncertain, right? Because you have not done any experiment in the past. You have not done any event. So you have no idea. This is a new condition for you. So you don't need to specify any prior in that condition. All right. The fourth point is otherwise provide a weak prior with exponential value. That's right. If you want to provide it, then you have to provide a complete range here because you are uncertain. So you have to, for example, prior is between 0 to 100 and I don't know the exact value. So I will provide the complete range 0, 100, right? If it is exponential, then I will provide from 0 to the any exponential value, right? And it can be in middle of that. So that's why it is a weak prior, and it can be a vague prior if you provide the complete range because you are uncertain about it. Next is weakly informative prior. First point, you can see that it provides partial information about variable. You are getting information, but partial information, not the complete information about that parameter or variable. The second point is it should provide enough information for regularization. So should be enough information, but it can be partial. Third one is rule out unreasonable parameters. So if there are any unreasonable parameters are available, then you can rule out them. The fourth point example is there, weakly prior distribution of temperature in an area. So if you are trying to gather information about the temperature of a particular area, and if you want to provide the probability or if you want to gather information about the prior, so for example, mean temperature is 50 degrees Fahrenheit, right? And there's a deviation of 40 degrees Fahrenheit. So you are not certain about it. but it is not vague prior. It is a weakly informative prior, right? You have information, but that is partial. You are not sure about it, that what is the exact temperature or what is the exact mean temperature. You have just idea about it. For example, 50 degrees are the mean temperature and there is a deviation of minus 40 or plus 40 degrees inside it. So what will be the range here? The range will be 10 to 90. So you can see here 50 minus 40 equal to 10 and 50 plus 40 equal to 90. So the range will be 10 to 90, and that is a weakly informative prior. It is not a vague informative prior or vague prior where the range is not small, the range will be in exponential values. So this is basically called weakly informative prior. So these are the basic information about various priors.